So, as always, the code for this question will be in the description, but if you want the explanation, you can watch this video. Although I think this question is actually really easy because I don't know why this is in the this is the third question of the contest, yesterday's contest, but the question actually is really easy. There's just a small trick in it. You write the test case down, you write the test case for any of the test case down, you write how this thing works, how they asked it, and you'll see that it actually works pretty easily. You'll understand it while I write it down. So, if you look at the question, they're given us that we'll be given two integers n and k, and we'll be given an array. Now, what we have to do here is perform a particular operation k number of times. Here n is the length of the array. This is the array itself, and k is the number of times we are supposed to perform an operation. The operation being that out of this number, these numbers, we need to find the least non-negative integer which is not in this array. The least non-negative, which means from 0 to any number, the least of that number which is not in this array. Now, if you look at this thing, we have 1 to 5, all these numbers, but 0 is missing. So the number is 0 here. Now, for each and every element, we are supposed to consecutively replace them with the least non-negative number from the array which is not in the array. So for example, here we have 1, right? So 1, 2, 3, 4, 5. 0 is not there. 0 is the least non-negative number, so we'll replace 1 with 0. Now we'll replace 2 with the least non-negative number which is not in this array, which is 1 in this case. We have 0 and 2, 3, 4, 5. So 1 is the least non-negative number, so we'll replace 1. Similarly, if you look at this thing, we'll again have, in this case, we'll have 2. In this case, we'll have 3. And in this case, at the end, we'll have 4, if you look at it. So, this is one operation. So, when k is equals to 5 here, this was one operation. The individual changing of the elements is not one operation. You need to change all the elements in the entire array for one operation to be counted. So now k will be 4. So similarly like that, you have to do it for now right here again. In this case, if you look at it, it will be 5 actually. I'll tell you how. And then it will be 0 and everything. And so on and so on. You will go k to 3, and to 2, then to 1, and at the end to 0. So, given this thing, if we are given an array and a k, the value of k, you need to print the output array. Now, I'll write it down. I think you already got the answer when I explained the test case to you. 1, 2, 3, 4, 5. Right. Notice one thing carefully. When I wrote the previous example, if you see, I erased the number and I replaced it with the minimum number which was not in the array. But for the rest of them, the number I wrote in this position was the number I erased in this position. And the number I wrote in this position was the number I erased in this position. Let me tell you what I mean. Now, you look at this array. 1, 2, 3, 4, 5. K is 5, right? So initially, we'll write it down like this for simplicity's sake. We'll rub these. So now k is 5 here. Now, the minimum number here is 0. Right? Now, we'll start with the operation, which is what will we do here? We'll have 0 here of 2, 2, 3, 4. Right? This is the array we'll get if we do it. Okay, it will be 4. We still have 4 operations left. So, if you look at this thing, these numbers are the same. And now, if you look at the next example, the next iteration, you will understand it more clearly, which is, if you look at it, from 0, 1, 2, 3, 4, we have from 0 to 4 all the non-negative numbers. So the next least number which is not in it is 5. Yes. They didn't ask the minimum of this in between this array. They ask the number which is the least possible non-negative integer which is not in this array. And 0 is in this array, 1 is in this array, 2 is in this array, 3 is in this array, 4 is in this array. The only least possible number is 5 which is not in this array. So 5 will be the number. We'll replace 5 with 0. Now 5, if you want to look at the example, what I mean is, like, if it's 5, it will be 1 2 3 4 here again, and I told you all of that. So with this one now 0 is not there, so it will become 0, and this will become 1, and so on and so forth. What you'll get is 2 3. Now as always, these are equal, and this number 5 was here. If you look at that thing, now we have 3 operations left. Similarly, if you look at it again, these are basically the example test cases here. So again the same thing, again the same thing, again the same thing. Now if you look at this number, 4 was here, 3 was here, 2 was here. Now with this thing, I think if you still don't get it, it's basically like this. Take this entire array, forget about this line, take this as an entire array. What you're basically doing here is, now you'll understand this thing much more clearly. We are basically right circular shifting the array by 1. That's it. That's as simple as it is. For each and every iteration, we take the minimum number here initially, which is 0. Then we start right circular shifting this thing. So 0 and 5, 0 will go here, and the number will shift here, and 5 will come here. Similarly, when we circular shift this, 4 will come here and this will go there. 3 will come here, and 2 will, and 1 will. So basically, what we need to do for this number is, we don't need to find out the minimum possible number for each and every element, whether it is there or not. We do it for k times. No, just have to basically take the minimum for initially what is the minimum number, append it here, and then we need to right circular shift this thing till we get k is equals to 0. That's it. Basically, that's the intuition explanation for this code. So now this thing, there are still a few caveats here, which is, caveats means there are still a few points here which we need to take care of for this thing, because we don't know where 0 will land. We don't know whether 0 will land here, because we need to print this array at the end. We don't need to look at these elements. Once we circular shifted these numbers, when we print the array, it should be from here to here. We shouldn't look at these numbers. These numbers should be invisible to us. These numbers don't matter. So at the end, the answer for this is 23450. That's what you're supposed to print. So in order to know where the L numbers will land, that is a bit tricky too. You can right circular shift this thing number, but for how many positions, that is also important. So which leads me to the code explanation, which is basically, it's a small thing, but I still have to explain things. So now with this one, we are in the code explanation now. When it comes to the code, everything is actually perfectly clear. The first thing you're supposed to do is, if you're given an array, let's write it down again, 1 2 3 4 5. We have these numbers. What we basically have to do is simply take the frequency of each and every number, and we take this number and then we look at the least possible number which is not in this array. You know that thing, the code is already there if you want, but it's easy for us to do that. After we get the number which is 0, now here comes the trick. which basically is that we just take this number and we create a new array. We create a new array which is like this. Now, what you'll do is, at what position will 0 be? What, for example, if in that case 0 was here, so what position is 0 in? It's in 5th position, which is 0, 1, 2, 3, 4, 5. The index is also the array number, so it's in the 5th position. 0 will be in the 5th position at the end. So we are supposed to right circular shift this number 5 times. Now, how did we get to this conclusion? This is where the position thing comes in. So, position is equals to k percentile n plus 1. That's it. Simple. Basically n plus 1 because the length of the array here is n, and plus 1 you're adding another element, so n plus 1. So k percentile n plus 1 will give you the position of this separated number after we perform k operations, which means after we right circular shift it k times, we'll get it 0 here. Since if you look at it, if k 5 percentile 6 is 5, I hope so. 5 percentile 6 is 5. K is here 5. Percentile n plus 1, 5 plus 1 is 6, is 5. So 5 percentile 6 is 5. So the position of k is 5. Remember, the position of 0 will be 5 here. Position of 0 is 5. Which means that we're supposed to right circular shift this number 5 times. What will we do if we get it at the end? I don't have to rub all of this. Just get here and rub this number. And since we'll get this number like this actually. If you right circular shift this number 5 times, you'll get this. Now we need to remove this element from this because there are only 5 elements, not 6. So what we'll basically do is, the number resulting in the array we get, result, we'll just take it from 1, which means that we'll start from the first index and remove the 0th index, and that will be the new array. So with this one we'll get the number we want, and after that we can just print it. So as you see, if you just wrote down the test cases, if you took one test case and actually wrote it down, you would have got this intuition yourself. But it's a bit tricky, yeah, I know, but I don't know why they put it in that position, because it's, I think, one of the most easiest questions I've solved throughout my entire code courses time I have been here. So yeah, if you want the explanation, yeah, the code is in the description as always, and thank you.